there are two situations are occurring here. The rod is moved towards right with a constant speed. Oh, I think let me put. Okay, there's our rod. So initially it is at a distance. So it will have resistance. Let me indicate it here. So it is initially at a distance, say x naught or 1 meter. I'm going to drag it after some time. Finding very difficult, you should take up of diagram, or else you should have this basic imagination. So this will be, it is a t equals 0. So it is moved with a constant speed. So what can be this distance should be 1 plus Vt. And in fact, B bar is varying with the time. So what about the flux linking this? Flux linking this should be equal to B into area of the loop at any time. B bar is 1 minus 3t. So what about area? 1 plus Vt. So I want EMF induced, so d phi by dt. Or let me first simplify this. 1 plus Vt minus 3t minus 3Vt. V is how much? 4, no?
Minus 3Vt square.
3Vt square. Yeah. So this will be minus 1 minus 7t. We'll differentiate this. We'll get EMF induced. Minus 7 minus 6Vt. V is, I think, 4, no? Minus 7 minus 24t. Oh, okay, this one here.
That is plus V, sir.
Okay, wait. 1 plus Vt minus 3t. Yeah. 4t minus. Okay, this will be only plus t. I'll write one more step here. Here we'll write it here. 1 plus 4t minus 3t minus 12t square. Okay, I'm doing correction, ma. Yeah. So this will be 1 plus t minus 12t square. So let's differentiate this. 1 minus 24t. Find the work done by extrusion to move the rod. Okay, so only this particular is having a resistance. So there'll be EMF induced, so a current I will flow. Now what about direction of current? Yeah, it will be in this direction. So this I is equal to E by R. I'll do all that calculation part here. This will be I is equal to E by R. E is 1 minus 24t by, this is 10. Then the action agent should apply force in this direction. BIL force will act here. Find the work done by the action agent to move the rod with a constant. Question is there? Okay, that's. Let me check question. Constant velocity for 5 seconds. I think I missed it. The rest of circuit is resistanceless. Yeah, only this is what RE is given. And there is some data missing. I just added it. For 5 seconds, what is work done by that? So look at the extringent. So we have to get this work done. How to get the work done? Because the force, let's calculate external force first. We'll see what we'll get. So what is the external force I should apply? Equal to BIL. B is what? Function of time 1 minus 3t. Expression for current 1 minus 24t. Length of the rod is 1 meter. So the force is varying with the time. How to bring the work done when force is varying with the time?
Sir, that divided by 10, sir.
I is equal to, okay, this 10 is missing, no? Okay, yeah, fine. How to bring the work done? So actually the power generated by extringent should be equal to F into V. So we know F external. So this is what dW by dt you're going to write it, no? So this equation will be 1 minus 3t. Further V will be 4, this will be 2 by 5. So dW equal to 1 minus 3t. I'll write it below, no space here. One minus 24t 2 by 5. So this I'll integrate. I'll get the work done for 0 to 5 seconds. What should be the limit? The limit should be 0 to 5. I'll give answer later on, you check it. Sir, what about that induced electric field? All can we totally avoid that induced electric field? Who is responsible for flow of current? Potential difference or induced electric field? Anybody wants to answer? Because if I just come out of this problem, okay, mathematically we are doing, that's all. But let me just have analysis here. Who is doing who is responsible for flow of current?
Potential difference.
Both.
Both. Answer should be both here.
Sir, the BIL force should be in opposite direction and current should also be in opposite direction. Because inward flux is decreasing with time.
Flux is decreasing with time or increasing? You check
Decreasing.
it. Then extringent should move towards left, in the sense. I'll change it. High will be clockwise, huh?
Yes, sir.
Okay, if I is clockwise, then BL force will act towards right and away from the left end. Oh, some problem we have here.
Sir, negative flux is decreasing, so anti-clockwise.
Flux at any time t, no? This is
Clockwise and this is.
E equal to minus d phi by dt. The formula should be E equal to minus d phi by dt. The flux is varying with the time. I think it should be of this kind only.
No,
Shall
sir,
I?
opposite it should be.
Will be in opposite direction. Huh?
Yes, sir.
Clockwise only, sir.
Clockwise only. Huh? Then clockwise means BL force will act towards right. Then X agent should apply force opposite to this one. Yeah, okay, no problem. Yeah, we can change it. Okay, you'll see like I'll change it. So then to maintain that constant speed, no, so I'll apply force.
Sir,
Yeah.
Sorry, correct only,
first,
sir. Correct.
first it will increase, then it will decrease. First
Oh,
flux will increase, then it will decrease.
for 5 seconds, sir. Because for 0 to 5 seconds, we are analyzing here. Say anyway,
1 by 24 seconds.
First 1 by 24 seconds, it will increase, then it will decrease.
First it will increase, then decrease. Huh?
Yes, sir.
1 by 24. Huh? 0 to 1 by 24 it will increase.
Yes, sir.
Yes, sir.
Afterwards it will decrease. Huh?
Yes, sir.
Oh, then what we do? But anyway, X agent will adjust. Okay, first he has to
Answer
do.
will be same only.
Answer will be same only. Okay, anyway, like he has to see that velocity of the rod
Direction
is
of force.
constant. No, yeah. You should see that the speed of the rod should remain constant. So opposite to BIL, you will change the direction of force also. Rather than showing one direction, it depends on time, that one. Huh? Okay, the speed of the rod is constant, so it doesn't matter for us. Like first what happened, you have to adjust himself the direction opposite to BIL. Equal to minus d phi by dt. Only magnitude I calculated. I just directly took that flux is increasing. Negative flux increases, d phi by dt negative, EMF induced positive. Okay, I'll do one thing. I'll just retain the same direction. Huh? Just I think to get answer, very simple.